Welcome at the Wireless Classroom. In this video series, I try to explain the basics of electrical engineering with sample calculations. If you think this video is helpful, please hit the like button and subscribe to the channel, which helps me to produce more content. In today's video, I will explain how we can simulate the calculation from last time, where we used Ohm's law to calculate all the current and voltages in the circuit. The free program we will be using is LT Spice. Link to the website will be in the video description below. In order to build our own circuit, we need a drawing board, therefore we go to New Schematic on the top left. First of all, we insert all the devices and start with the battery. This can be found by clicking on the component symbol and searching for voltage. There we can find the voltage source which represents our battery. Next we need to get our resistors, so we click on the resistor button and insert 3 of them. Now we can edit the names and or values of the devices by right clicking on every single one of them. Next we have to insert the ground because voltages are measured towards the ground in the simulations. Finally we connect the devices with each other using the line tool. Note that you can draw the line through devices and they will be connected properly. Now we start to simulate by clicking on the guy which runs away from us. LT Spice will ask us some simulation parameter. However, for us only the stop time is important. We set it to 1 and press OK. Measurements will be shown in the top part of the screen. We can measure voltage or current or even both at the same time if we want to. For measuring voltage we have to click on the wire between the devices. To measure current we have to do the exact opposite and click on the devices themselves. If we hover over either a wire or a device, we get a different probe symbol. Let's start with the current. As we know that the current is the same through all the resistors, it does not matter on which one we click. We can see that the current is 1 amp. If we left click on the legend, we get a menu where we can see the exact number as well. Very well. This is the same current as we have calculated. In order to have a better overview in the next part, I will remove the current for now. Let's move on to the voltages. The voltage on resistor R1 should be 6 volt and the voltage on the 2 remaining resistors should be 3 volt. It is very important to understand that the LT Spice measures the voltage always from the point of the probe to the ground. For example, if we click at the top, we will get 12 volt. Why is that? Because we measure from here to here, which is the voltage of the battery. Note that this voltage is the same on the right side, which means that the sum of the voltages on the resistors has to be the same as the voltage of the battery. On the top you can see that the voltage is named like voltage from net 001, which is not really intuitive. This can be changed by inserting labels. Let's insert some labels. For top, V23, which equals V2 plus V3, and for V3. We remove the old voltage measurement and rerun our simulation because we have modified the schematics. We can click on our new labels to see the voltages. The y-axis is currently not nice, therefore we right click it and set the bottom to 0 and the ticks to 1000 millivolt. In our measurement we can see that the voltage from top to ground is 12 volts. This is the battery. The voltage V3 on resistor R3 is 3 volt, which is what we have calculated as well. Now the difficult part is to understand why V23 is 6 volt when V2 and V3 should be equal to 3 volt. V23 is measured from above R2 to ground, which is in fact V2 plus V3. This is not exactly what we want to show, therefore we can subtract V3 from V23 and get V2. As we have argued in the last video, we measure the voltage positive from the top to bottom on each resistor. Measuring V2 can be done by holding Ctrl and then hold left click on V23. Drag the mouse over to V3 and lift your left mouse button. We get another entry in the legend called V from V23 and V3. This is now the voltage V2. Left clicking on it shows us that it is exactly 3 volt. We can as well try to measure the voltage V2 in the other direction, which swapped the sign of V2 in our calculation. That is, we got V2 equals minus 3 volt instead of 3 volt. As we can see, this also holds true here. This brings me to the end of this video. Thank you for watching.